The topic of this video is from Unit 4C on range and standard deviation. In the previous part of the unit, we looked at measures of central tendency, what was happening in the center part of your data. But now we're going to look at measures of dispersion that describe how spread out the data set is. The range and standard deviation are measures of dispersion that we're going to take a look at. We'll first of all look at the range. The range of a set of data is defined as the difference between the largest value and the smallest value in the data set. For this example, let's find the range of the data set. Now the range is defined as the difference between the high value and the low value. Now since this data is already given in numerical order, we can easily identify the high value as 50 and the low value as 2. So the range of this data set is equal to 48. Now because of outliers, the extreme high values or low values, the range is not always a reliable measure of dispersion. A better measure of dispersion is the standard deviation. It is based upon the distance of each data point from the mean. The sample standard deviation is given by the following formula. So let's identify what all the variables in the formula represent. S is the sample standard deviation. X minus X bar is the deviation of the data point X from the sample mean X bar. N is the number of data points. Now you'll have to use the square root key on your calculator. Okay, every calculator is different about where the square root is located. Right, but you will need to find that on your calculator. So let's look at an example. Let's find the standard deviation for this data set. We'll need to round our answers to 1 decimal place. Now the first thing we need to find is the sample mean. That will be used in the calculation of the standard deviation. So remember the sample mean, we represented that by X bar. That was the sum of all your data points divided by how many data points you have. So the sum of all these data points is 63, and there are 9 data points. So our mean for this data set is equal to 7. Now we're going to use this mean of 7 in calculating the standard deviation. So what we've done here is created a table to help ease the calculations, try and keep everything in order. We've got a column for our X values. Those are just our data values from the previous slide. Now the middle column will be the deviations from the mean. And in the last column, we're going to square the deviations. So let's fill out the second column knowing that the mean is equal to 7. Now remember we found the mean on the previous slide. So X bar was equal to 7. So we're going to subtract 7 from each one of these data points. So 12 minus 7 gives me 5. 14 minus 7 will give 7. And we'll just do this all the way down for each data point. So what those numbers represent in the second column are the deviations of the data point from the mean. So in this last column, we're now going to take each one of those deviations and we're going to raise it to the second power. So 5 squared, that's equal to 25. 7 squared is equal to 49. Now on the next one, you do want to square the negative 5. Not just the positive part. So that will give me a positive 25. Negative times negative does give me positive. So if you are entering that on your calculator, be sure that you put parentheses around the negative to simplify it. So I'm just going all the way down and calculating the squares of these deviations. Now in our formula, if you look over here on the right hand side for the sample standard deviation, we need the sum of all the deviations squared. That's going to be the sum of this third column. So on this third column, let's find the sum of that entire column. And that sum is going to be equal to 154. That will be the number that we plug into the formula for sample standard deviation. All right, now this will be underneath the square root. The number in the numerator will be 154. Now remember what n is. That's the number of data points that we have, and there are 9 of those. So we have the square root of 154 divided by 8, which simplifies. And actually, before we simplify it, if you want to enter it on your calculator with the parentheses, let me show you how to do that. Just make sure that you put 154 divided by 8 inside the parentheses underneath the radical. Now the direction said to round this off to 1 decimal place, so that rounds off to 4.4. Now that is your sample standard deviation.